Hello friends, welcome back to the third video, that is Bioinformatic Tools. Today we'll be discussing with a new um, tool, that is a molecular visualization tool. So just see what is it. So a molecular visualization tool, first of all, it should be very clear. It's a software. And what is it being used? It is used to view a structure of what? A macromolecule like protein, a nucleic acid, etc. There are so many tools available in under this category, online as well as offline, which help us to visualize such biomolecules. And these help us, that is, these help the user to manipulate the structure image. And it is being done using an interface, that is GUI, that is graphic user interface. And the user can in this using this visualization tool, what are the user being benefited? The user can view the image. He or she can handle it by rotating, by zooming, or drawing it in different forms. And this can create models of different styles like wireframe, ball and stick, ribbon, space filling styles. We'll just see what are they. See, wireframe style is a line drawing that represents the bond between the atoms. And so this is the first picture shows the wireframe style, and it displays a skeletal form of a molecule. Another form also we can interchange between the different forms, different styles. So this is another style, ball and stick. As the name indicate, the atoms will be represented by balls and the bonds by the sticks. And third one is ribbon model. Here the spiral ribbon, or in the cylindrical form also, this can be represented, alpha and the beta plates. The fourth one is the space filling style, in which the atoms are represented by solid spheres, while the radii are in proportion to van der Waals atoms. And the most common software used to visualize, to go with the molecular visualization, there are so many software like KIME, CN3D, MAGE, JMOL, PyMol, and also Rasmus. But here we should know, in your syllabus you have to study about Rasmus. So Rasmus can be uploaded from this site, and here it is a molecular graphic program. And again, what is it? It's a molecular graphic program, and its purpose is to visualize what? Macromolecules like protein, nucleic acid, and small molecules. And here it is one of the popular used open source program, and it was being created by the person August Sale in the year 1993, and it is being maintained by the University of Massachusetts. Rasmol, here we can say it is the short form of rastering molecule, and it is a very highly efficient program, and it gives so much of utilities to the users, like the user to depict and explore the three-dimensional structure of a chemical and the biological molecules. And the structures will be presented in this Rasmol software in the form of standard PDB format. And it is a command specific, that we have to give command. We have, if we want to make a change, we have to give commands. But then you will be under a confusion. Oh my god, how can I give a command? I'm not a programmer. But then this commanding is being made very user friendly, and it can be easily familiarized. And it is a stand-alone program, and that require very little hardware. For running it, we don't need an extra uh, hardware. Then here we can say that this is a very small program, and to make it so it is since it is just consumes very little data or the space, it is highly portable and easy to be installed. And we all can also have a install plugin also. It has a user-friendly interface also, that enables a user to view the molecule being investigated by, like, if the user wants, he or she can rotate it in any angle, zoom in and out, or it can study the conformation of a domains motif. We want to study a particular point motif, then we can we can zoom over it, and we can have the idea about all those active site of enzyme can be studied by this. And as I said earlier also, it can be viewed in different forms like spacefill models, ribbon models, strands model, etc. So Rasmol have its own significance in the field of bioinformatics for visualizing the functional groups, to understand the active sites, to know about the probable location where the inhibitors or the modifiers normally binds on the protein. All these can be understood using this model. And the program is aimed to display, to teach, to generate publication quality images, to give, to provide all the known protein a particular structure, and it has been stored here, and so we can get a better idea about a macromolecule. And it can be run in any operating system like Windows, Apple, Macintosh, Unix, or VMS systems. So that's all.